Good morning, afternoon, or evening. How you doing today? Today we are going to get to your favorite part, which happens to be word problems. I say that sarcastically. Most people are definitely afraid of word problems, but with the new skills that we've learned, being systems of equations, we're going to make things a lot easier, I think, in my opinion. Because now that you have a system, you're going to be able to work with two different variables. Okay? Later on, after the word problems, I'm going to show you how to set up a system with three different variables. But for right now, you have two different variables, and you know how to solve systems now. So your thinking has to change a little bit with these word problems. We have solved these word problems using one variable. And we would make a table, and we'd call the unknown x, for example, and then whatever changes happen to x, we put that in the other column, and then we put it together, and it would total something. And that's fine and dandy. That works great. But this is a lot more powerful, and it gives you a lot more breadth of understanding of word problems. For example, the sum of two numbers is 45. Twice the first number less the second is 27. Okay. Think systems of equations here. They're giving you information to set up two equations. The first thing they told you is that the sum of two numbers is 45. That's the first thing they tell you. So let's go ahead and write that down. Let's call the first number x, and let's call the second number y. I really don't care what variables you use, but I like to use x and y a lot. So I know that the sum of the first number plus the second number that means equals 45. Boom, I have my first equation. That's it. I have my first equation. Now, what other piece of information did they give you? Well, they tell you that twice the first number less the second is 27. Well, guess what, guys? That's another equation. Let's do it out. Twice the first number. We had determined that the first number is x. So twice the first number less the second minus the second number, which we defined as y, means equals 27. Does that make sense to everybody, what I just did there? Do you guys see how that's a little bit easier than what we used to have to do before? Okay? And it's a much more complicated word problem, even though it's just two sentences. We could do this another way, but it's a lot more complicated. This way, you set up two equations, you set up a system, and boom, you solve. So now, in this particular case, we'll do it in green. This is Mickey Mouse. The y's cancel. 3x equals 72. Divide by 3 to both sides. X will equal 24. So my first number is 24. My second number. How do I get my second number? Well, now that I know what x is, can't I just plug that back into either of the original equations? So I have 24 plus y equals 45. Subtract 24 to both sides. And y equals 21. And there you go. That's my answer. Does that make sense? The key here is not solving the system. I'm sure you guys can solve the system. I know you guys can solve the system. The challenge here is setting up the proper system. Let's think about a similar question. The sum of two numbers is 104. How can I represent the sum of two numbers is 24? Yes, sir, my brother. There you go. X plus y equals 104. The only caveat is warning. The only caveat here, label your variables. Please, I'm telling you, that's half the battle with these problems. And that's where a lot of my students get messed up and they can't solve the problems. It's not because they don't know what they're doing, they just don't label. Okay? So let's call this first number. I'm going to call it x. And the second number, I'm going to call it y. All right. So we know the sum of two numbers, the first number plus the second, is 104. The second number we defined as y. So the second number, y, is, that means equals, 25 less than the first number. So what do you remember about less than? That means flip it, switch it. Very good. So 25 less than twice the first is 2x minus 25. Does everyone see that there? Yeah? All right. So now let's go ahead. In the first example, we use elimination. What do you guys think would be the easiest to use here in this particular case? Substitution 100%, because you know what the y is already. So you've got x plus 2x minus 25 equals 104. Okay? And you've got x plus 2x is 3x minus 25 equals 104. I'm going to add 25 to both sides. And 3x equals 129 divided by 3. X equals 43. Does that make sense? Now that I have x, let's go ahead and plug it back into either of the original equations. I would plug it into that because I'm looking for y. So y equals 2 times 43 minus 25. So y equals 86 minus 25. So y equals 61. Yep. So my solution, 43 is my first number, 61 is my second. First number, second number, and you're done. Yes, sir. Okay, the question is, we have to put it in an ordered pair. You know, not necessarily. No. As long as you label it, first number's this, second number's that, yes. Because even though I put in the ordered pair, I still labeled it first and second. So just make sure to do that. Thank you, sir. Yes, sir. No, the question again was, if I labeled it as x and y, and I go ahead and just use an ordered pair, and I say x is 43 and y is 61, is that still accurate? Will that be acceptable? Yes, it would be, because you defined it up here at the top. Okay? Does that make sense, y'all? So that's direct translation, nice and easy. Let's do some geometry word problems. The Gomez family just bought a wooded lot that is on a lake. They want to enclose the lot with a fence, but do not want to put up a fence along the lake. John Gomez determined that he will need 240 feet of fence. He also knows that the width of the lot is 30 feet less than the length. What are the dimensions of the lot? Okay. Besides the very pretty picture here, they give you a lot of information here. You just got to know how to use it. The first thing is they want to enclose the lot with a fence, but do not want to fence along the lake. So what's happening here, if you can see, okay, you've got a fence that's going to go here, it's going to go here, it's going to go here, but they want the lake free. They want to be able to, I guess, see the lake, right? They want to see that lake. So that's going to be fenceless. They want to have the scenery. They determine that they're going to need 240 feet of fence. Well, perimeter is the sum of all sides of a shape or a figure or some sort of area, okay? It's the sum of the sides. It's the distance around that shape. So in this particular case, the perimeter, which is 240 feet, because that's how many feet of fencing we have, is going to equal 2 times W plus the length. Can everyone see how it's just one length because I am not fencing the lakeside? Does that make sense? All right, so we've got our first equation. But he also knows that the width of the lot is 30 feet less than the length. So the width of the lot, which is W, is 30 feet less than the length. Less than, so that means switch, so that's L minus 30. Does that make sense to everybody? Okay. Now at this point, now it's Mickey Mouse time. Substitution, whoever said that, thank you, it's fantastic. So I've got 240 equals 2 times W, which is length minus 30, plus length. So I've got 240 equals 2L minus 60 plus L. I got 240 equals 3L minus 60. Add 60 to both sides. Add 60 to both sides. So I got 300 equals 3L divided by 3. My length will be 100 feet. 100 feet. Does that make sense so far, everybody? Now that I have my length, I'll change colors. Now I can go ahead and plug that into my W here, my width. So my width will equal 100 feet, which is the length, minus 30. So my width is going to be 70 feet. So the length is 100 and the width is 70. Yes, sir. Again, would you have to put this in an ordered pair? No, not in this case. If you so chose to, you could, because as long as you remember that an ordered pair, it's ordered by alphabet. So it would be the length, 100 feet, and then the width, 70 feet. Okay? But in this case, it was L and W for length and width. Pretty self-explanatory. But thank you very much. Good question. Does that make sense? All right, next. A rectangular field has a perimeter of 400 yards. The length of the field is 3 times the width. What are the dimensions of the field? Let's just think about what a rectangle is. I know you guys know what a rectangle is. I know. However, I like to always go over this just to make sure that you all remember the formula for perimeter, because it's very simple if you can visualize the actual rectangle. When you have a rectangle, again, I'm not trying to say you guys don't understand this, but the width's equal on both sides. And when you have a rectangle, the length is equal on both sides. So when you take the sum of all sides, the perimeter for a rectangle will be 2 times the width plus 2 times the length. That's just something that you want to know. That's something good to know always, not just for this question, but for always. You want to remember that forever. So let's go back to our equation, or our word problem real quick. The rectangular field has a perimeter of 400 yards. Well, guess what? If you know your perimeter formula, you already have your first equation, okay? You can say W is width and L is length. Okay, so you're going to have 400, which is the perimeter, equals 2 times the width plus 2 times the length. You have your first equation. Second equation. The length of the field is 3 times the width. So the length, L, is equals 3 times the width. Boom. I just set up my system. Now, solving. I know that at this point, solving's Mickey Mouse for you guys, so let's just get to it. I'm going to use substitution, of course, because they told me what the length was. So I got 400 equals 2W plus 2 times 3W. So I've got 400 equals 2W plus 6W is 8W. Divide by 8 to both sides. And that's exactly right. Thank you, sir. 50. And we're talking about yards. So my width is 50 yards. Now I want to find length. Well, it's real easy because we already know what length is. Length is 3 times the width, and the width is 50. So my length is 150 yards. And there you go. You found the width and you found the length. Does that make sense to everybody? Yes? Okay, give me 1 second. Okay, thank you guys. Let's continue. Let's do a couple more geometry problems, and then we'll go to the real fun ones, which is the distance. That's what you guys always love. Yeah, don't stress, don't stress. It's pretty easy. All right, let's find, for example 5, find a measure of two complementary angles such that the measure of the larger angle is 6 degrees greater than the measure of the smaller angle. Let's just really quickly have a little mini review. Complementary angles. Complementary angles, my friends, are angles whose sum is 90 degrees. So when you have two angles that add up to be 90, that's called complementary. Okay? Complementary. And then you also have supplementary. And supplementary angles are angles which form a straight line. So in other words, they have a sum of 180 degrees. Okay? So those are just two facts that some of you probably know. Maybe you forgot. Maybe I just reminded you. But it's good to know these things. So now let's get back to our word problem. Find the measure of two complementary angles such that the measure of the larger angle is 6 degrees greater than the measure of the smaller angle. This is a very confusing one for most people. And that's because they don't remember the first basic equation. If they're telling you right off the bat, find the measure of two complementary angles. Well, if they're complementary angles, don't we know already that the first angle plus the second angle has to equal 90 degrees because it's complementary? Boom. That's the key here. That's my first angle is X, and I'm going to call my second angle Y. All right? I could call it whatever I wanted. Yes, sir. Yes, you could have done a table for all of these, but this is so much simpler than a table. Yes, sir. Actually, you know what? They didn't say first and second. Thank you. My labeling was kind of bad. I appreciate that, sir. I'm going to call X my larger number. Thank you. I should have read. I should have been more careful. And Y is going to be my smaller. Thank you very much. Very good observation. It's not first and second here. It's smaller and larger. And it's a little mistake like that that I would have made that could have cost me the difference at the end. You know, thank you very much, sir. Awesome job. So now, we know that the complementary angle, so X plus Y is 90. Cool. But now they say that the larger angle, that's why it's so important what my boy just said, the larger angle, which we called X, is 6 degrees greater than the measure of the smaller angle. So it's 6 degrees greater than Y. Done. But if you don't know that first equation, X plus Y equals 90, this can get very confusing, okay? Now, I know that I'm going to use substitution here. So X is Y plus 6 plus Y equals 90. I've got 2Y plus 6 equals 90. Subtract the 6. 2Y equals 84 divided by 2. Y equals 42 degrees. Awesome. And now that I know what Y is 42, I can easily solve for X because that's 42 plus 6. So X equals 48 degrees. Bless you. So my larger angle was 48 degrees, and my smaller angle was 42 degrees, and 48 plus 42 does equal 90, so it all works out. Yes, sir. Okay, the question is, if I had such a simple equation, would I have to show the work? Okay, I'll be fair with you guys. I'm going to be looking for definitions, labels of your variables. You have to set this up for me. There's just no choice. And then this part here, yes, I went step by step. If I was doing this for real on a real test, I probably would have skipped, me personally, I probably would have skipped all of that. And I would have gone right to that. I would have said, okay, 2y, I'm going to subtract the x. So yes, within reason, I will let you do some work in your head, my man, for sure. No, thank you for asking and caring. Does that make sense, guys? All right, let's move on. We got plenty of time, but let's move on. Okay, find two supplementary angles such that the measure of the larger angle is 16 degrees less than 3 times the measure of the smaller angle. Again, we've got a large, small angle here. I'm going to call x the larger angle, and y is going to be the smaller angle. Please, guys, don't be afraid of using any variable you want. I just like to stay consistent. I don't like to confuse myself very much, so I like x and y. So I know they're supplementary. So that means the larger angle plus the smaller angle must equal 180 degrees. And I know that the larger angle, which we defined as x, that means equals 16 degrees less than 3 times the measure of the smaller angle. So that's 3y minus 16. Now, again, bless you, I'm going to go ahead and solve by substitution. So I'm going to plug in that 3y minus 16 for the x value, plus y equals 180. So I've got 4y minus 16 equals 180. Again, some of you are going ahead of me, and I understand that. You're doing some stuff in your head. That's cool. 196. Divide by 4 to both sides. So y will equal 49 degrees. What is x going to equal? Well, x is going to be 3 times 49 minus 16. So that should be 131. Correct? Yeah, 131 degrees. So my larger angle was 131 degrees. My smaller angle was 49 degrees. When you add up 130 plus 49, you will get 180 degrees. It all works. Does that make sense, guys? Do you find this to be a little bit easier than the old method that we were doing it? Right? It's a lot more powerful. Well, guess what? You could use this always, forever. May I continue? Okay, thank you, guys. Okay, last two, your favorites. Motion problems, okay? Distance. Remember, the best thing I can do for anyone here is to remind them about the very powerful table. I know that some people don't like the table. They're like, oh my God, this guy with the table. But trust me, the table is gold. It's gold. Rate times time will always equal distance. And then here is the event. Whether you're going to or from, or going home and then to the store, plane A or plane B, train A or train B, okay? That's the table that I just use over and over and over, and it's my savior for this. It's what helps me understand this. So, okay, let's talk, guys. The airspeed of a plane is its speed through the air, hence the airspeed. This speed is different from the plane's ground speed. Its speed relative to the ground, okay? Nothing too difficult about that. Both the airspeed and the ground speed of an airplane is affected by the wind. And if you think about that, all of you have ridden bike or gone on a skateboard or maybe been on a canoe. When you're going against the wind, does that speed you up or slow you down? Right, it's a force opposite of yours. So it's going to slow you down. When you're with the wind, though, it's almost like someone's pushing you, right? You have to pedal less. Every time you walk or run, it's a little bit as if you're going a little faster. If you're on the water, every time you paddle, it's like an extra boost, right? That's going to add to your speed, correct? Just think about those things. Okay, suppose that a Piper, it's a type of small little jet, a Piper aircraft flying west against the wind, okay, a distance of 500 miles takes 5 hours. The return trip flying east with the wind takes 4 hours. Find both the airspeed of the plane and the wind speed. Okay, guys, let's not stress. Let's make a table. My rate times time will equal a distance. What are the events here? Well, the event is 2 and then return. Yes, I know. Give me 1 second there. Okay, thank you. Sorry about that. So, let's just go ahead and fill in our table. We're going to first talk about the event 2, going 2. The Piper aircraft flying west against the wind, a distance of 500 miles, takes 5 hours. Well, we know distance is 500. We know it took him 5 hours. Now, the rate. He's flying and he has a wind airspeed, okay? An airspeed. He's flying. And he's going against the wind. So wouldn't the rate be the plane's airspeed A minus the wind speed W? Do you guys see how and why I did that? Because the plane has a speed. It's an airspeed and it's flying. It's going forward, right? But if it's going against the wind, think about what we talked about when you're riding bike. Is that going to slow that plane down or speed it up? It's going to slow it down. It's going against it. So I'm subtracting here. Does everyone see that? Yes, sir. Absolutely what I was going to do next, sir. A is airspeed. Thank you, son. And W is wind speed. Excellent, excellent, excellent. Now, the return trip. The return trip flying east with the wind takes 4 hours. So the plane's airspeed plus the wind allows them to get there in 4 hours. Same distance, though. Now, we have a system that we just created. I've got 5 times rate times time equals distance. Rate times time equals distance. Let's go ahead and distribute. So I've got 5A minus 5W equals 500. And I've got 4A plus 4W equals 500. I'm going to go ahead and eliminate. Okay? So I'm going to multiply to my top equation. I'm going to multiply 4. And to the bottom, I'm going to multiply 5. So that's going to give me 20A minus 20W equals 2,000 plus 20A plus 20W equals 2,500. The W's cancel out, and I've got 40A equals 4,500. When I divide by 40, A will equal, I think it's 112.5. Yeah. So that's 112.5, and this was miles per hour. That's my air speed. Does everyone see what I did there? You know? Now that I have my airspeed, I can plug it into either this equation or this equation. I really don't care. I'm just going to plug it into the second one, easier numbers. So I've got 4A plus 4W, which is 112.5, equals 500. Come again? Oh, thank you. Pay attention. Thank you. 4 times A, which is 112.5. Thank you so much. I've got to pay attention. Plus 4W equals 500. That's going to be 450. Yep. That's 450 plus 4W equals 500. 4W equals 50. So W equals 12.5. Yes?
Why is it 4,500?
4A does not equal 4,500.
48 4,500. Why is that?
Because What's 2,000 plus 2,500, my brother?
How do you get the 2,500?
Because I multiplied 5 to 500. Remember, I have to multiply that to everything on both sides. Thank you, my brother. So in the end here, my airspeed, 112.5 miles per hour. My wind speed, 12.5 miles per hour. What's really important here, though, is using logic to determine if that's reasonable. Is that reasonable, guys? On average, the wind speed is going to be less than the plane's airspeed, correct? Unless, God forbid they're in a storm. Hurricanes can have winds of up to 200, 250 miles an hour. But does that make sense, this answer? Yeah, it's always good to think about the logic about making sense of that, okay? All right, guys, let's do our last example. Did that make sense, by the way? Did you understand that? See how that table made it a lot easier? If you don't make that table, it's going to make things a lot more difficult for you guys, in my opinion. Okay. A plane flew 1,200 miles against the wind in 4 hours and returned while flying with the wind, not is, but in 3 hours. In 3 hours. Find the airspeed of the plane and the wind speed. All right, cool beans. Okay, sorry about that. Okay, so I have rate times time always equals distance. My event, it's a 2, and then a return again. Says here, plane flew, or you could even go with or against, right? With the wind, and then against. However you really want to set it up. It's up to you. Whatever makes sense to you, really. Bless you. So a plane flew 1,200 miles against the wind in 4 hours. So that's airspeed minus wind speed, where A equals airspeed and W equals wind speed. Okay, awesome. The return flight, while flying with the wind in 3 hours. So the distance still is the same, 3 hours. With the wind, though, it's an addition. So now I have a system. I've got 4A minus 4W equals 1,200. And I've got 3A minus 3W equals 3,600. No, what's wrong with me? Equals 1,200. Sorry. System of equations, I'm going to solve by multiplying the top by 3, remember, to both sides, and the bottom by 4 to both sides. Yes, sir, please. Yep. This is plus here because it's going with. Thank you. Excellent. All right, so I've got 12A minus 12W equals 3,600 plus 12A plus 12W equals 4,800. The W's cancel. I've got 24A equals 8,400. Divide both sides by 24. A will equal 350 miles per hour. So if A is 350, how do I find W? Plug it into either one of the original equations. So I've got 3 times A, which is 350, plus 3W equals 1,200. That's 1050 plus 3W equals 1,200. Subtract 1050 to both sides. 3W equals 150 divided by 3. W equals 50 miles per hour. And again, does that make sense? Having an airspeed of 350 and a wind speed of 50? Yeah, that makes sense. It's rarely going to be the other way around. Because what happens if the airspeed is stronger than the wind, I'm sorry. What happens, think about this logically. If the wind speed is stronger than the airspeed, well, what happened? You would be going backwards. Thank you. Very good. Very good. Okay? So thank you very much. Hope you learned a lot. Have a wonderful day, y'all.